Now we'll do a question where you have a jogger who runs towards the mirror and you want to find out the speed at which the image changes in the mirror. This is a question from your book. A jogger is running at a speed of 5 meters per second and you have to find the speed at which the image moves when the jogger is at a distance of 39 meters from the mirror. Given the focal length of the mirror is 1 meter, and this is a rear view mirror, and rear view mirrors are convex mirrors. So here we're doing a numerical and I'm going to give you hints. I'm not solving the entire question and I'd expect you to solve the question on your own. So this is a convex mirror here. A convex mirror bulges outwards. You can think of this like the tummy of a fat person. So this is a convex mirror. Now the jogger is at a distance of 39 meters from the mirror. So this distance is 39 meters. Now first of all, since you have a convex mirror, what do you have to think of? You have to think of which formula to apply. 1 by V plus 1 by U equals 1 by F. And the next thing to recall is the sign convention. So what is the focal length of a convex mirror? It is positive. So it is plus 1 meter. I like to remember it this way, that you have an X and the X in convex looks a little like a plus sign. So the focal length of a convex mirror is positive and the focal length of a concave mirror is negative. The object distance will always be negative because this will be the direction of the incident light and you are measuring against the direction of incident light. So we know that U will be negative. V in this case, let's find out what is the value of V. Now the speed of the jogger is 5 meters per second. So what you will do is you will take the position of the jogger at 2 instants of time which are 1 second apart. So suppose this is the initial distance of the jogger from the mirror, which is 39 meters. In 1 second, the jogger moves up by 5 meters. So the new distance of the jogger from the mirror will be 39 minus 5 meters. So the first time you solve the question for the first part, so what you do is 1 by V plus 1 by U equals 1 by F, and you know the value of F, you know the value of U, so you find the value of V. So I'll call this 1. So this is U1, V1, and you find out the value of V1. Then after that, what do? You're taking the position of the jogger after 1 second. So once again you will apply 1 by V and I'll call this V2, and U2 is equal to 1 by F. Of course it is the same mirror, so the focal length will not change. Now U2 in this case will be 39 minus 5 and you have to put the correct sign with it and you find out the position of the image. So which means you know V2. You solve that. So now you know the position of the jogger at 2 instants of time which are 1 second apart. So from the difference between these two positions, V1 and V2, so let's say earlier the jogger was here, now V2 will be here, the jogger, because the jogger is approaching the mirror, the image will also appear to move towards you if you are viewing the image from this side. Let's say your eye is placed here. Now take the two positions, find out the distance by which the image has moved and divide it by 1 second, because you're finding this in 1 second. So that will give you the speed at which the image moves in the mirror. Then you can solve this question for different positions of the jogger. If you look at the question in your NCERT textbook, you will find that there are some other positions of the object which are given. So you solve all those parts also. In case of any difficulty, you can ask me, you can put a question over here. You can put a question in the comment section. Thank you.